Okay, good evening. So let us begin with the first question on criterion A. The figure below shows a 12 volt battery connected in the circuit containing resistors A, B, C and D. Each resistor has a resistance of 6 ohms. So each resistor has a resistance of 6 ohms. I will write like this actually. Now calculate the combined resistance of the resistance A and B. If you read the question carefully, he is only asked you the combined resistance of resistances A and B, which means that I want only this resistance only. Okay, do not take the parallel, series, everything and do it. Just take this two. What is this now? It's just 12 ohm, right? 6 plus 6 is 12 ohm. Only write so much. I don't go beyond this. Okay, next. Resistors A, B and C. Now he has asked you what is the effective resistance of this full combination. So how do we do here? So these two are in series. Let me write down. So these two are in series, which gives you 12 ohm over here, and this one is in parallel. I want only the effective resistance between these two. Only this branch I want. So what will this be? This would be 1 by Rp will be equal to 1 by 12 plus 1 by 6, which would now be equal to, what do we have here? Let us take the LCM as 12. 12 1 here and 6 2s are 12. So 2 1s are, so it will be 2 here. It should be 3 by 12. 1s are 3 4s are. So you get 1 by 4. Is 1 by 4 the resistance? No. Because 1 by Rp is equal to 4. Rp should be equal to 4 ohm. Okay, 4 ohms. So let me write down this as 4 ohm. Okay, so we have done for 2 of them. Then resistors A, B, C and D. All the 4 years asked. Okay. Now what should I do? We already found out the full A, B and C, which is nothing but 4 ohm. Now this 4 and 6 are in series. If you want, I will write down this circuit also here. So now the circuit looks like this. This is your battery. This is your 4 ohm, your 6 ohm. So totally how much is it? 10 ohm. Okay. Thus, now we have done all of them. Now calculate the current in the battery. How do I find the current in the battery? So once I find the total resistance, what is the total voltage? Total voltage is 12 volt. So what is the current in the battery? Which means whatever current is being derived by the full circuit, the same current enters the circuit like this. So this is the current in the battery, right? So what I have to do? I have to just write this as, this is your 12 volt over here. So that's what I do. I have to find out what is the current I should be equal to P divided by R total. What is R total? It is nothing but 10 ohm. And what is V? V is nothing but 12 volt. What is the current here? 12 by 10, which is equal to 1.2 amp. This is a very straightforward question aimed at determining how do you compute the resistances, how do you use Ohm's law and all this. Okay, next. The energy transferred from the battery to the circuit in 50 seconds. It is asking you what is the amount of energy transferred from the battery to the circuit. So what is that you need to do? You need to find out energy. How do you find out energy? Energy is nothing but the power multiplied by time. You know how to find out the power here. What is power? Power is nothing but I squared multiplied by R multiplied by T. What is I? I is the total current which is entering the circuit. What is that value? 1.2 amperes. 1.2 square multiplied. What is this R here? R is nothing but the total resistance. Where is it? It is 10 over here, right? Because he is asking you for the total circuit. He is not asking you for one particular circuit, one particular resistance. Full circuit is asking. So I will write this as 10 multiplied by, what is the time taken? 50 seconds over here. So let us compute this. Where is my calculator? Let me pick up my calculator. Have your calculator with you. Start working on this so that you also get to have a feel of this. 1.2 to 1.2 multiplied by 10 multiplied by 50 is 720. 720. What is the unit here? Energy. Whether it is kinetic energy, potential energy, thermal energy, electrical energy, whatever it is. The moment you talk about energy, it should always have an unit equal to joules. So it's 720 joules. Okay, next. Let me move on. In the above figure, a 12 volt battery supplies a current I to a circuit. Okay, so current I is being circuit to a circuit. The circuit contains a thermistor and a 1000 ohm resistors in parallel with a 500 ohm resistor in series. So he says the circuit contains a thermistor. Which one is a thermistor? I do not know. 1000 ohm resistors in parallel. So this should be definitely a 1000 ohm resistor. Okay, and with a 500 ohms resistor in series. So what is this question aim at? The question aims at whether you are able to identify, okay, what is the circuit component given something in the description. So this should be your 500 ohm resistor. Somewhere there should be one of them should be a thermistor here. A or B should be a thermistor. I do not know which is it, which we need to find. And then I do not know what is B. Let us see. Then at a certain temperature, thermistor has a resistance of 1000 ohms. Calculate the combined resistance of the thermistor and the 1000 ohm resistor. Now he says one of them is a thermistor, the other one is combined resistance of the thermistor and the 1000 ohm resistor. So this could be, let us say for example, if B is 1000 ohms, so here this is 1000 ohm here. This could be your RT, R thermistor. Okay. At a certain temperature, thermistor has a resistance of 1000 ohms. Find the combined resistance of the thermistor and the 1000 ohm resistor. So I will combine these two resistances and I will find which is now equal to 2000 ohms. Right? Let us see. There anything else is given here. 1000 ohm resistor in parallel, 500 ohm resistor in series. Right? Okay. Next, the current I. What is the current I? So here I don't combine resistor, thermistor and the 1000 ohm resistor. So this is your 2000 ohm. While doing this, what I have assumed is that I am assuming that this resistor is 1000 ohm. Okay, I have not considered this one here. Okay, so only between these two I have considered. Okay, now the current I. If at all, if it was explicitly been given to you that find the combined resistance of A, B and C, then you can consider all the three. Okay, next. The current I. Which current I uses? This current I. Right? So what is the value of the current I? So again, like the way how we have done previously, we are going to do the same problem once again. So current I will now be equal to V divided by R total. What is the R total here? So this is also 1000. This is also 1000. This is 1000. So let us find out, okay, the total resistance. Now what did we do earlier? We found out the effective resistance of these two, right? Inner parallel circuit we found out. What was it? I will write it as 1 by RP is equal to 1 by 2000 plus 1 by 1000. Okay, this is very similar to what you have done earlier. Only thing is that the numbers are changing. That's it. Okay, so which should now be equal to, what is this now? The second, take LCM as 2000, 1 plus 2, which should be equal to 3 divided by 2000. R parallel should be 2000 divided by 3. Then what is this? This is this resistance, 2000 divided by 3. And then you have a 500 once, right? So that also you should count. So your R total now be equal to, this will be in series with this, like the old one we have done. So this will be 2000 divided by 3 plus 500, which will be equal to how much? 500, so 1500 plus 2000 will be 3500 divided by 3. I'll just keep it like this. Okay, I'm not going to simplify it, putting it into decimals and so on. Okay, let me not waste my time. I'm going to use this. It is 3500 divided by 3 ohms. So now what we do is, we'll write here the current I. How do you find current I? Total potential difference by total resistance. What is the total potential difference? Let us see, 12 volt once again. This will be 12 volt divided by 3500 divided by 3, should be 12 into 3 divided by 3500, which is 36 divided by 3500. Okay, let us now use our calculator. So this will be 36 divided by 3500, which will be equal to 0.01. So that writes as 0.01 amps. The potential difference across the 500 ohm resistor. What is the potential difference across this resistor? So what happens? The current that comes here, it splits into two parts over here, and after this it comes here, it joins together, and the same current comes here also. Whatever current was coming here inside this circuit, the same current is seen here also. What is the potential difference here? I times R, right? So we already found out the value of I. So value of I is equal to 0.01 multiplied by 500, which is equal to 5 volt near. Okay, so 12 volt was applied, 5 volt is being seen over. Okay, like the temperature of the resistor is increased so that its resistance decreases. Temperature increases, resistance decreases. State the effect of this change in resistance of the current through the 500 ohm resistor. Explain your answer. What happens to the current, the effect of this change in resistance on the current through the 500 ohm resistor? What will happen to the total current? What is the current initially we had? We had a current of 0.01 amp. 0.01 ampere. When the temperature is raised, R thermistor will decrease, right? When R thermistor will decrease, let us go back to the circuit. When this value decreases over here, the effective resistance will now decrease, right? This resistance will decrease and the parallel with them, what will happen to them? Let us say, for example, let us use some numeral value. Okay, only then we get a clarity on it. Okay, so what we'll do is let us say this becomes, let us say 500 for example. Okay, so now what will happen? The circuit now looks like this. This is your RTH would be 500 ohms. So this is not changing. The other one is once again 1000, and this is once again 1000. This as usual it looks like this. Okay. Now let us see what will happen to the current. And you had a 500, right? So what will happen to the resistance first? So this will now be equal to 1500, and this will now be equal to 1000, right? And thus, if I take the parallel of this one, what will happen to the parallel of this? Okay, this will retain as such here. This will be retained as such over here. Will be retained as such over here. And if I take the parallel here, what will happen? 1 by R3 will be equal to 1 by 1500 plus 1 by 1000. Okay, these are not changing, so I'm writing like this. So I will take what could be the LCM? LCM could be 3000, for example. Be 2 plus 3, which is equal to 5 by 3000. Rp would be equal to 3000 divided by 5, right? Am I right? 1000 3s are 1500 3s are, that's right. Okay, so which should be 5 6 are 30, which should be 600 here. 600 now. This resistance now becomes something like this. 600 here, 500 here, which will be equal to 1100 ohms. And here, what was the reason? If I do not use this simplification, if I do not use 500 ohms over here, what was the resistance earlier? Let me go back. Earlier, the resistance was around 3500 divided by 3. How much was this? Let's calculate this also. This will be around 1000, 1, 3 ones are 3, then 15, 3 5s are 3 5s are 15, so 3 ones are 1500 divided by 3. Right. Let me use the full calculator over here. 3 will be 1166. 1166.67. Let me compare the resistance over here. So earlier it was 1166.7. Now it has become 100. What is happening in that case? Then the resistance is reducing. When resistance is reducing, what will happen? I, which is equal to V by R total, now increase, right? So the current through the resistance of 500 ohms will increase. Okay, this is what you need to mention. Okay, I hope this is clear. So thank you. We have seen the criteria A. Tomorrow we will see the criteria B.